now that we have seen that an SHM can be characterized with this formula over here, it's time to just get into the nitty-gritty technical terms of certain things in an SHM. So of course, the graphical representation is one of a sinusoid, as you see over here. Okay, now some technical terms. So we describe the maximum displacement from equilibrium, which is here, as the amplitude, right? And we typically call this x naught. Okay, and of course it goes both ways, so this is negative x naught, right? So that's the amplitude. Let me write that down here, right? X naught. Now also we have these points over here. This is the time taken to complete one complete cycle. We typically call this the period, or big T period. And so some other terms that you might want to be familiar with, of course, is also the frequency of the SHM, which is the number of complete oscillations per unit time, and is typically given as 1 over big T. Now, one more thing, okay, we have something called the angular frequency. Let me spell that out. Angular frequency of the SHM, and it's written as omega, which equals to 2 pi over T, or of course 2 pi f. Now this will look kind of familiar for those of us who have seen the circular motion videos. In circular motion, we call this the angular velocity, and you know that the formulas are exactly the same, right? It's just that when we do something like SHM, there isn't actually a physical angle that's changing. So we have to use a different name, out of respect for the fact that there isn't a physical angle. And so we just call it angular frequency, but for all intents and purposes, it is almost identical. So this is the rate of change of phase as compared to this guy, who is the rate of change of angular displacement. But they are essentially the same thing.